space, and we will now deep dive into this discussion and talk about everything here. So I'm Tanja Wente from Goldeimer. We basically talk about shit every day. You can see us in the Pipa Pool Garden as the rest of us here. Yeah, that is something that it connects us all here. And before we begin, I would like to ask you all a quick question. And if you can answer this question with yes, please raise your hand. Do you use a toilet? Have you ever used a toilet? Or do you poop? Please look around. I feel that every one of us poops. What a surprise. This is something all of us have in common. So let's talk about this. One thing before we start to deep dive on the connection of poop is that I would quickly bring some attention to something that actually sets us apart, because not everyone has a toilet to do their business. To be exact, 3.6 billion people don't have access to toilets. I think for us, it's quite normal here in these buildings that we have a toilet that we can use, that is clean, that works, where the logistics behind is clear, but that's not, that's a privilege that we should actually acknowledge. Because yeah, on the other hand, some people don't even have a toilet, and here, as Anastasia already mentioned, we just flush everything that we leave behind with around about 8 liters of clean drinking water, while 771 million people worldwide don't even have access to clean drinking water. So just to raise this thought and let it sit here, I am happy to have 3 wonderful scientists on my stage today, on my side today, to discuss the connection between toilets, sustainability, and the universe today. And I have to say that I'm quite proud that we managed to do an all-female panel, because this is not usual in the scientific area and I think everywhere. So let's give this a round of applause. Thank you for being here. All right, we will discuss questions at the end. Quick organization: if you do have questions, please take your cell phone out and go on menti.com and enter the code that is written here, 94087727. It will be displayed in the presentation later as well. You can just drop in your questions and we will talk about them at the end.
There will also be the microphones, so you don't need to use Menti, but it's an opportunity.
Okay, if you want to note down your questions during the panel already, feel free to do it here. All right, let's start. We have here on my side Ariane. I will go back 1 second. Ariana Krause is an industrial engineer by education, and she now works as a postdoc scientist at the IGZ, which is the Leibniz Institute of Vegetable and Ornamental Crops, just a little bit south of Berlin, so she's actually a local. But she is also coordinator of the Zirkulierbar project, which you can find in the Pipa Pool Garden just outside of here. It's a research project which creates one of the first real laboratories for sustainable regional circular economy. So Ariane has worked with dry toilets for quite some time, and she basically wants to recover nutrients from consumed food and return them to agriculture. Ariane, I have a question for you. So what was actually the source of fascination for sanitation? Why do you work with poop?
Thank you. Maybe you can. It was this person. This is my colleague, Ibrahim Bamuhiga Bitakwata. So I was living in Tanzania I was working in Tanzania from 2010 till 2015. And I was developing appropriate technologies, initially for cooking. And I was interested in how to use the residues after cooking, namely biogas slurry or biochar, to bring it back to the soil for the nutrients, but also to improve the soil fertility. So my interest was the use of the residues in agriculture. And when I was living in Tanzania, in Karagwe, Ibrahim was one of my closest friends and colleagues and also teachers. So he told me about how smallholder farming works, how closed cycle agriculture works, how intercropping systems works, and all together. Ibrahim died today 1 week ago, so I'm still sad about this, but I wanted to dedicate this also to him. So I want that he can rest in peace. I will miss him a lot. Ibra tuna kukumbuka sana. And from Ibrahim, so I learned about agriculture, but what I've also learned from him, that it was us Germans in the 60s, in the early development cooperation projects, that broke the closed cycles that they had in smallholder agriculture by introducing pit latrine toilets. So the nutrients were no longer brought back to the soils, but they were stored inside the toilet. So he was sending me on the mission to think about how can we use now our engineering skills to reduce the pathogens and to recycle back the nutrients to the soil in like modern ways. So he sent me on the mission, actually. It was him who sent me on the, when my journey to the toilet started. It was his idea to collect the nutrients again from the toilets and bring them back, but without risk. And then I was continuing to live there. I did my PhD. I did a couple of field experiments. We constructed toilets, we produced recycling fertilizers, and I used these recycling fertilizers in demonstration plots in agriculture. And what I saw was, for example, that we could increase the maize yield by 3 or 4 times compared to the standard way of farming there. And that was very convincing and very motivating for me to continue with this topic. But I also decided that I want to focus on my own backyard now, because what Anastasia already explained a little bit, our system here is also not a healthy system, even though at the beginning it was a big health contribution. So that's why I continued with this topic, still with the focus on the recycling fertilizers and the quality assurance. And I like this topic also because I think the way we treat our own poo is so symbolic for the way we use resources in general. So that's what I like on this topic. And it's always interesting to talk with people about it.
Yeah. All right, thank you. I would like to continue with Anastasia because I think you have quite a similar background, maybe, at least you both definitely work with the nutrient cycles. We already heard your stake on poo today, so we kind of know where you're coming from. Just for everyone here to get to know you, you are an environmental engineer as well, with, of course, a devotion to toilets on organic waste. You worked on nutrient circularity in Brussels, in Belgium, for your PhD. And before that, your work on people's poop already brought you to Switzerland, Egypt, Germany, and Namibia, right?
Indeed.
So that's a lot of poop you have worked with. Very good. And now Anastasia works at INRAE in Rennes, France, for Become, a project on the development of future trajectories for urban organic waste. So Anastasia, for you as well, where did your journey start, and kind of what has sparked your interest in all of this?
I actually connect very much with the last point that Ariane just made. The fact that how we treat waste is very telling of how we also treat our resources. I think it's important, and to me, I was not realizing for quite a while that the line that we draw between the waste and the resource, it's not to be taken for granted. It's a line that comes out of social and cultural circumstances, out of the economic system. So once I realized it, and I think the first time I did, it was during a master course I did at my master's in Zurich, on water and sanitation, also in developing countries, where I really saw the absurdities, like how some people don't have access at all, how here we are completely mistreating the resources. And then it was then that, out of frustration really, that I wanted to do more that and to work more on that. So from there, I went on a journey where nutrients was usually, or it was always the red thread. I worked on nutrient flows from very small villages in the Nile Delta to Brussels, a big metropolis, where I also saw a bit more, let's say, worked a bit more on the aspect of connection, where I also talked about, because we have a city and we often say, okay, but if nutrients are coming out of this city, but we don't have any agricultural land in the city to reuse them, what we should do and where they should go, and if they are coming from all over the world as food in a city, does that mean that we have to get them back to these places to close the circle? So these are all very interesting questions. And I think that has been a bit the red thread on my part, like trying, let's say, to make the nutrients come from the waste side to the resource side, or maybe even better, to move the line or erase it altogether. It's, these are the questions I'm occupied with.
All right, thank you. And as you can see, we have someone else here on the panel. I am happy that Lisa Deutsch is with us today because she brings in a little bit different perspective today. She conducts her PhD in the Inter- and Transdisciplinary Research Group of the Department of Environmental Social Sciences at EAWAG. And in her PhD, Lisa, you look at how the integration of perspectives across different scientific disciplines, but also across science, policy, and practice can be led for developing sustainable solutions. So I think this will be a very interesting perspective that you bring in here today. And you don't only do the research of that kind, but you're also leading inter- and transdisciplinary program, the WINGS program at EAWAG, right? Can you tell us a little bit about that? And for you as well, coming from this perspective of, inter- and transdisciplinary leadership and collaboration to, sustainable sanitation, how does that come together?
Yeah, thank you, Tanya, for the introduction. I was always interested in what actually happens when different scientific disciplines come together and jointly look at a topic as complex as sustainability, because I think it's clear that such a topic can't be addressed from a single perspective only. But also what happens when scientists actually start crossing the borders of academia and start engaging with actors from policy and practice? What kind of ideas and innovations emerge from such collaborations? And I personally started first out with a strong social science background in political science and sociology, but then at some point became quite unsatisfied with looking at sustainability or topics related to it from only one angle. So I started to dig deeper into ecology and economics to at least cover, let's say, these three typical pillars of sustainability. But then when you start looking into technologies, you start engaging with engineers. And if you start thinking about that we as humans also need to change our behaviors and attitudes towards the environment, then you're very quickly in the realm of psychology. So I really enjoy integrating those insights from different perspectives. But then also when we engage in this transdisciplinarity, so when scientists collaborate with actors from policy and practice, so what I mean by that is, for instance, representatives from the municipal to the federal level, professional water associations, and so on. And I think here it's actually important to leave a bit behind the idea of science only developing end-of-pipe solutions and products, so that you have this classical knowledge transfer, that you only start engaging with actors beyond academia when you have already your results, and then you translate them, and then you shift them over to the other sectors in society. But actually, what happens when you start including those actors from the very beginning in an iterative manner? And how did I end up working in the field of water and sanitation? So first of all, I think it's clear water is a precious resource, and sanitation is key for health and hygiene. We depend on this resource, and at the same time, I observe, for instance, in Switzerland, where I'm working, that when you go to fairs and events of sustainable building, planning, architecture, you hear a lot about reusing and recycling material. This is really a booming topic, but you rarely get introduced into the idea of recycling and reusing water, or that you can actually produce fertilizer out of urine. So the thing about a transition then towards such a more sustainable, maybe water sector way of dealing with water, this is where this program comes in that you mentioned, which is called WINGS. And this transdisciplinary program tries to actually bridge above all departments at our institute from the engineering science and the social sciences, but also integrate other actors. So indeed, proactively deal with the complexity such a transition involves instead of sticking to siloed solutions. And there my job is actually in creating this bigger picture of how the toilet is connected to the universe, but also making sure that the different disciplinary researchers also leave their universes and get connected.
Thank you. I think this is something very, very important because we're working on something big. And if you're now maybe asking yourself, why the hell are they talking about poop and connections and have really scientific programs about it, let us quickly set the scene a little bit. I think maybe most of you have seen these pictures already. Those are the 17 Sustainable Development Goals from the United Nations. And as you can maybe see, number 6 is clean water and sanitation. So it is actually one of the main global goals from the UN to give safe sanitation for all by 2030. So that may sound quite easy, yeah, safe sanitation for all, but it's actually a goal facing so many different challenges. And one that is something I briefly talked about in the very beginning, it's the whole point of access to sanitation, because we're talking these goals are for everyone. So we have the access for sanitation, and on the other hand, it, of course, and that is what we're going to focus on today, is the transition of water-based and our linear systems to circular, safe and sustainable sanitation systems. So today we want to lay the focus on this and dive into this. How does it work? Why do we need it? And how do we manage this transformation? And here in Germany, we call this the Sanitär- and Nährstoffwende, can be translated to sanitation and nutrient transformation. It's just like the energy transition, basically. I think Energiewende is something we all know, and it's a big topic, and we want to do this with poo and urine. So, Lisa and Ariane, who are sitting next to me here, have worked and co-authored on a political discussion paper on why we actually need this. So if you're interested, we already wrote this down once. It's called Ressourcen aus der Schüssel sind der Schlüssel. And I'm sorry for everyone speaking English here. This is a joke we can't translate. So at the very beginning of this paper, there are 3 reasons on why we need to talk about sustainable sanitations. And luckily, we have experts on this stage who can explain us and elaborate these reasons. So I would like to give the first question to Anastasia, because the first reason is recycle nutrients and close nutrient cycles. Can you quickly tell us why this is so important?
Yes, of course. So we mentioned before, I mentioned it in the opening talk, you also mentioned it, Tanya, that we do need all these nutrients for agriculture, and we do have them in our poo. So I think that, let's say, the question why it's so important, it moves into in these 2 axes. So on the one hand, it's important to stop producing so much synthetic fertilizer because it's bad for the environment. It has big environmental impacts. For example, nitrogen fertilizer is produced with this process called the Haber-Bosch process, which is very energy intensive and very CO2 emissions intensive. Actually, what is happening there is that we take nitrogen from the atmosphere and hydrogen from natural gas, and in very high temperatures and very high pressures, we make them form ammonia. So for these high temperatures and these high pressures, we have to feed a lot of energy in there, and so we have a lot of CO2 emissions. It is actually estimated that up to 1% of the global energy use is going into this process. I think that it's around 20 or 25% of the European of the energy used in European agriculture. So we are really talking about a lot of energy there. And on the other hand, we also have phosphorus fertilizer that it's made from mined ores, mainly phosphate rock. And these ores are not infinite, so they are a resource that it's not going to be there forever, and it's also a resource that it's not equally distributed all over the world. For example, in Europe, we are dependent from outside, mainly China or Morocco, to have our phosphates for the agriculture here. Plus, also producing these phosphorus fertilizers is a very wasteful process. So this is the one part. So we can stop or minimize doing these processes that are so harmful for the environment. And on the other hand, we have the thing that we do have, it's very bad housekeeping not to be using what we actually have. And I think that sometimes we may be thinking that this is not very much what we produce as humans. It's not so much, so we shouldn't bother. But this is not the case. It is actually, wait, I have my numbers here because I'm a scientist. So we humans actually, we produce between 2 and 7 kilograms of nitrogen per year, depending on diet, between 0.5 and 1 kilogram of phosphorus, and between 0.5 and 2 kilograms of potassium. And 70 to 90% of that is not utilized. This really is wasted. And that means that different scientists have done different estimations, and they are, for example, estimations that say that this phosphorus of all humans in all the world, it could replace up to 22% of the phosphorus needed in agriculture. In Sweden, there was the estimation that indeed it will, human excrements could cover between 23% of the demand for nitrogen and 25% the demand of phosphorus. I did the calculation for Belgium, and the numbers are the same. So it's really not negligible. And on top of that, coming, for example, because talking for a country like Belgium, where I worked, we often say that, but we have so many animals, we have so much manure, why bother with the human excrements? Well, I also say to there that as we will have to eventually move to less livestock, to dealing better with all the livestock there, away from diets that contain meat, then that will become also more important, what we have as humans. So there.
Wow. So I think those were some pretty impressive numbers. I just want to say that if you all are impressed by these numbers, and if you want to donate actually some of your nutrients in your poop, we actually have outside in our Pipa Poo garden some dry toilets from Finizio, a company who actually recycles human waste into a very, very fertile fertilizer. So you can go take a poo here live at Republica and donate your poo so that we can make some super extreme nice humus out of it, and we would be happy if you join us in this mission. Just a quick sorry but I think thank you for the numbers. So I think this definitely shows how big the possibilities are as well. And I think going to the next reason. We now heard about nutrients and the possibilities that we have, the nutrients that are inside what we leave behind. The second reason for a sanitary transition is to save water and energy. And the third reason is to actually eliminate pollutants. And I can sense that some of you might be interested in the topic of pollution and human waste because it's quite sensitive, but I'm pretty sure that Ariana can tell us about all of this. So what does sanitation have to do with water shortage, pollution, and climate change?
Yeah, I will try, and I will start with water and provide you another big number, because I don't know if you know, but about 1/3 of the fresh water or drinking water that each of us consumes every day is only used to flush down in the toilet. So if we sum up the amount of water from 80 million people living in Germany, this comes up to the amount of water that is inside the Müritz, which is the second biggest lake in Germany. So this is a huge amount of water which we just use for the toilet. So in face of climate change, we need to rethink the system. So we need to rethink this water consumption. Water scarcity will also be an issue here, But again, we are on the privileged side of this world, so it will not be the hardest problem for us, but it will be a very hard problem for many other countries. So that means if we continue with the water-based sanitation system, this is not a sanitation system for all. So we need to develop new technologies, and we also need to think about a system change. So I think this is clear. So we need to save water, because it's a lot of water that we are using, and we don't know if we will have it in the future. And also already not everybody has this amount of water available. And yeah, for the energy, which is connected with this. I continue with the pollution first, sorry. So as Anastasia also said in her talk, so this water, mainly drinking water, is now mixed with excreta, so with the nutrients, but also with a lot of other substances. So this picture, you don't see it so much, but you see this very light point in the middle, that's Berlin. Around is the world map. So this world map shows nutrients that are diluted into receiving water bodies, like rivers, lakes, and the ocean. So most of the nutrients are not removed into the sewage system. Only about 50% is removed. The other 50% is just diluted into the water bodies, where they feed algae and where they cause at the end something that is called eutrophication. So there's a lack of oxygen in the oceans, for example, which causes the death of fish and other animals, marine animals. The other 50% that is not released to the oceans or to the rivers is removed. But again, we need to put a lot of energy to bring back the nitrogen that was taken from the air to the fertilizer with a lot of energy. Now we use again a lot of energy to bring back this nitrogen from the sewage sludge into the air. So there's estimations that a city of like Berlin or Eberswalde, but also small villages, they use about 15 to 25% of their energy consumption is only for removing nitrogen again from the sewage system. So there's a big potential now also to save this energy, because this energy consumption is related to greenhouse gas emissions at the same time. So yeah, fostering the climate change. And also behind these yellow dots, what I wanted to mention is, yeah, you don't see it so much, but you can see Europe, you can see America a little bit, and you can see China. So that means this is a problem also of the so-called improved sanitation systems. So also our sewage system is not a sustainable one. Sorry, I need to have a look here. What I wanted to mention now, coming to pollution, is that below these dots, where we bring back, where we remove nitrogen to the aquatic system, to rivers and the ocean, that is the same for potential pathogens, like diseases that can make us, or germs that can make us ill again, but also for pharmaceutical residues. Because at the moment, they are not removed, or mostly not removed from the sewage system. So what we do, we just dilute this into the environment. So this is a big reason also why we need to change and think about new systems on how we can remove these pollutants, but not dilute them in the environment. And the problem also with the system that we have at the moment is what Anastasia said, but with the wastewater system, we mix a lot of different wastewater streams. So we have a huge volume with valuable resources like the nutrients, but also pathogens or polluting substances like pharmaceutical residues, and it's very difficult to separate them again. Like you have a look at the landfill of solid waste, it's difficult then to get the paper out or to get the plastic out. So what we started in order to have recycling systems is that we separated our solid waste. And the same is now for the wastewater system. We need to separate the different wastewater flows, and then it will make it possible to treat them appropriately, to recycle the nutrients, but to eliminate the pollutants and stop polluting our environment with just diluting and distributing it and spreading it everywhere. So that means that the sanitation, so source separation is one approach for sustainable sanitation for all, and we have some solutions for this. So that means, first of all, we need to have water-saving toilets, like dry toilets. Sorry. So we have these toilets here. Maybe you've also seen them on festivals, but you can also have them as public toilets or indoor toilets, like toilets that don't use water, toilets that separate the flows at the source so that we have the efficient treatment. So we have also an example here for a very modern separating toilet. It's called SAFE because we want to save the nutrients. And this, it looks like a normal water toilet. You don't see it, but the urine is going a special way and removed. So this toilet allows that we take the golden flow of our excreta, which also contains most of the nutrients, and then treat it to get back to remove the pharmaceuticals, but to recycle the nutrients. So this is also another option that is already invented and that we can use. And then if we have these like sanitation systems, we can recycle the nutrients, remove the pollutants, and we can create circular sanitation systems. And the products from this will be like a liquid fertilizer, which we can produce from urine. So it's basically a nutrient concentrate. It's a very valuable fertilizer for plants, especially in their like the breeding or the growing phase when they need most power. So I call it also like a booster fertilizer. We give them an energy shake. We give it to the plants in the intensive growth phase. And from the solid matter, we can produce a compost. And the compost is also fertilizing the plants, but it's also feeding the soil. It's taking care of our soil. It brings back humus to the soil, which allows the soil to store water and to store the nutrients. So it also makes our soil fit and ready for climate change that is also that is coming. And very important for this, like recycling fertilizers, is that they have a high nutrient content, and they are suitable as a fertilizer, and they have the low pollution characteristics. So we've also worked together with some colleagues sitting here on the first DIN product standard, so developed with the German Institute of Standardization. We developed the first product standard, so where we defined parameters that need to be analyzed in the product and also the methods that need to be applied in order to make sure that this is a safe fertilizer that can be brought back to the soil so that we can reconnect the food system and the food system, toilets, and then back to the food system. That was a very little outline about the technologies, but more you can find out in our Pipa Poo Garden. And the last thing I wanted to add with regards to climate change, this is another picture I brought from Tanzania. This piece of land, when I arrived there in 2010, was just a brown, like a slopey hillside, totally eroded, with no trees on there. And then we implemented composting toilets in a girls' secondary school. And this is only 3 years later. And we used this compost for planting trees on this area. So that was a very, very, very impressive observation also for me, that the trees were growing so fast and this fertilizer was so valuable, so that we turned an eroded and not very arable piece of land into such a beautiful fruit forest. So this is also another aspect of climate change and how toilets can be connected with climate change, because we can use it for reforestation of eroded areas.
Thank you. I think you just showed a lot of solutions already to the topics, and now this is very nice. You said it is related to climate change, and I think it became very, very clear now in all of the elaborations that sustainable sanitation, it kind of means to stay within the planetary boundaries. That we have to use what we already have, and we have to use the technologies that we already have to recycle it, and to bring it back to the earth. And I know, just very, very quick, because we promised to talk about the connection to the universe, so I just want to give you a little tip that you can exhibit today as well, because actually this whole topic of nutrient cycles is related to the universe. We have the DLR Institute of Aerospace Medicine right here with us. It's part of our Lutopia group outside in the Pipa Poo Garden. They brought their solar crop simulator, which is actually a filter system that converts human urine into a nitrate solution. right? Yes, a nitrate solution which then fertilizes crops and grows, for example, tomatoes in outer space. I'm a communications person, so if this was scientifically not perfectly correct, but the colleagues in our People Poo Garden are happy to help you so you can see these technologies that we're talking about, they are actually used in space as well, because the topic of recycling what we have and growing something out of it is so important for us to basically survive. And we've heard a lot of solutions already from you, Ariane. We know that there are dry toilets. We brought everything here in the People Poo Garden, and you can see all of this here and try all of this. Now I would like to also, looking at the time, what more do we need to do this transition? Because I think it became clear on why we need the transition, why we need a Sanitärwende, why we need to talk about sustainable sanitation. But, and I think, Lisa, this is your focus topic, how do we actually implement this change? What else does it need besides technologies and policies to do this? Do you have the perfect solution for us ready?
Of course, no. So the simple answer would be it's complex, but that's probably not a satisfying answer. I think the first important step has already been taken, that there are alternative technologies and systems to the current system. And that, for instance, this Laufen toilet that you just mentioned, I mean, it really looks the same as any other toilet that we used to use, and that also a high prestige company like Laufen actually decides to get into this business and start producing it. But the other thing is that also key actors for such a transformation and people in general need to know that these technologies exist. So I was wondering, for instance, how many of you actually did know about alternative sanitation technologies before coming to this session? So those who knew about it can maybe raise their hands. Oh, that's actually more than I thought. So one thing is knowing about the existence of these technologies, but again, this is not enough, because people also need to develop the intention actually to implement such technologies. And to develop such an intention, these technologies and systems need to satisfy the goals and preferences that people have towards such a system. And here I can give an example from our research in the WINGS program. A colleague, Philipp Beutler, actually accompanied 2 Swiss villages for the period of 4 years, who were faced with the decision to either renovate their big wastewater treatment plant for a lot of money, or connect again with major investments to the next village and to its proper treatment plant. And they were interested, what else can we do beyond these 2 options? And he first introduced also a couple of options, so this urine separating toilet, more decentralized wastewater treatment, and so on. And everyone was a bit skeptical. And what he then did was he conducted a series of workshops where he used a tool which is called multi-criteria decision analysis. And the only thing you need to know about the tool is that the inhabitants and the representatives jointly defined what do they expect from such a new system, ecological-wise, social-wise, and economic-wise. And what came out of this process was that the environmental goals were considered highly important, and that, for instance, the category low cost was an important category, but never the most important one. So they used this tool, and the results showed, everyone was surprised that, the alternative technologies did incredibly well. And suddenly both villages were actually more open to explore this option. And what then happened, the question that then arose was, well, where can we actually go and look at such implemented systems? Is there a village that is similar to us where we can go and touch and so on? And this brings me to another important aspect, and this is the role of pilots and Lighthouse projects. So visible implementation projects where people can go and experience such new systems. And I brought a picture of the Nest building, which is on our EAWAG and EMPA campus. You have office spaces in there, you have apartments, you have event units. And there, the water hub colleagues have implemented a source separation system. So, for instance, grey water, water from the kitchen sink and the shower and so on are separated from feces and urine. And the urine is collected, treated, and then turned into the fertilizer Orine that is also certified by the Swiss Agricultural Ministry. So I think these implementation projects are really important, and they're more and more on the rise, but they're still potential for more. And the third aspect that I want to quickly mention, because there's always the role of policies for actually encouraging the implementation of such novel technologies. Again, the design of such policies is not trivial, because two other colleagues, Josiane Coleman and Nadia Konsen, they looked at a policy that was implemented in Bangalore in India. So Bangalore was pressured to deal with the wastewater and to reuse it more. So they adopted a policy that mandated the implementation of decentralized wastewater treatment for non-potable reuse or irrigation and so on. And the two colleagues looked at the perceived fairness of that policy and found that actually many aspects were considered unfair by those people who had to implement it. So, for instance, industrial factories were excluded from that policy, and other people, for instance, were overwhelmed with the amount of water. They didn't know what to do with it during monsoon season, for instance. So, again, also designing policies, I think, shows again that it's an inter- and transdisciplinary act in itself, and it really makes sense to reaching out also to other actors and get their perspective on it when developing such solutions or policies.
So is that your main, because there are probably barriers to such approaches, it's always difficult to bring many perspectives together. What would you say is your one main conclusion of how to overcome these barriers? What does it really need to make such a transition happen?
Yeah, so I can mainly speak for science now, but I've also been told that this applies to the public sector and maybe also others, is at least in science, you don't get any flowers for reaching out beyond your own discipline. So the incentive structure in academia is structured in a way that actually rather encourages you to do your very specific thing in your own niche, while inter- and transdisciplinary collaborations are not rewarded. And I think that's the way. So there is this old saying, the real world has problems and the university has departments. And I think that also applies to the public sector to a certain extent. So I think we need to build transversal structures. So the program that we have at EAVAC is such an attempt, but I think those transversal structures also need to receive the same value and legitimacy actually for overcoming those silos. Yeah.
Thank you. We're very, very short on time, and I do want to squeeze one or two questions in. What I really like now about this kind of conclusion, what I heard is that you basically say it is about collaboration. And what's funny is if you look at the Sustainable Development Goals again, number 17 is partnerships for the goals. So I think the essence of all of this is that we need to work together, and that we need to think together and develop the solutions together. So I'm really happy that we are all part of the Lutopia focus here at Republica, and that Republica gave this a stage for such a collaborative partnerships, because here in the Peepapoo Garden at the panels, you can see different organizations, different scientists, different practice partners who work all together to make the sanitary change happen. Here's quickly, that's the logo that you will find us and the locations where you can find us. And now I would like to use the last 3 minutes for questions from the audience. I'm quickly checking Menti if anyone handed in some questions. But if there's a question in the audience, feel free to already reach out. I do think we have a microphone. Yes? While we
Hello. Yeah.
Perfect.
So I have two questions. One is how scalable is the project practically, especially in developing countries where open defecation is still a major problem. And also, I think Lisa had mentioned about Bangalore. I come from India. So what was the scope of the project within Bangalore? Was it replicable in other parts of India? Or why not? What were the challenges?
Do you want to?
Thinking about, I think in this, what I in this sanitation transition, it also means that we go into complex system and into very diverse systems. So we are developing very diverse and different kinds of technology. So that is one perspective of scalability also for me, that you develop different technologies for different locations so that they are appropriate. And that means that you may have in a village, you have different systems. You can have like the composting toilets because you have less distances also to transport the material. You can have like a central, in the village, like a central composting place, but it's still like a decentral system, like a nutrient, like a regional, very local nutrient cycle. But then, for example, for big cities, there are other options. For example, there are plans for the city of Paris, which is a big area, so that one new area will be implemented with this source separation toilets. So that means we still use some water as a transportation media, because in this very dense populated areas, it's a high value if you can pump and use like pipes for transportation. But we implement these urine diverting toilets. So we collect the urine separately, and by this you can already recover about 80% of the nutrients that are part of the wastewater system. And you also collect most of the pharmaceutical residues. So this is then another system that is scalable also for big cities. Yeah, so there are different scales and also different technologies. But that's also what I think is an aspect of sustainability, that we don't rely only on one technology, but that we develop different solutions for different regions. Yeah.
Yeah, maybe a quick comment to the question about Bangalore. So I wasn't the main investigator in this project, but what I can share from what I know from the colleagues working on it is that it's interesting. In Switzerland, we would like to see more implementation projects, but utilities are more hesitant, and it really needs to be perfectly proved until we start implementing that. And in Bangalore, the opposite was the case. So everywhere those decentralized reuse technologies popped up, but maybe without always a proper governance model, and not always with enough time maybe also to choose the right technology. So we have very different interesting cases, like different approaches. And now there is a new project coming up which will actually deal more intensively in how those technologies actually, whether they work well in Bangalore or not, and what governance models could improve them also on the long term. Yeah, but it's a very interesting case.
Maybe one more question that was handed in on Menti is because you mentioned the topic of open defecation, which is definitely a big problem in urban areas where sanitation access is not guaranteed. Living in the countryside, should I stop pooping into my toilet and find pooping on fields and near trees? What do we say to this?
What I've learned from Ibrahim, again, like this was the system, but what is very important is that you cover it afterwards. So, because we need to make sure that like fleas or like smaller animals, that they don't get in touch and start transmitting the diseases that are also connected. But it sounds very simple, but we can learn from old traditions and use them also for tomorrow and for future solutions. So this is actually an option. You can create a hole and also use this one, and then plant a tree and cover it with soil. And the soil, like if you collect it in an appropriate amount, that means that you don't dig a hole that is like 10 meters deep and you just store the huge amount of nutrients there, which is much more than this tree that you would plant on it uses. But if you use it at different places, this can be an option, but this does not solve the problem that you want to have privacy when you go on the toilet. So this is an option if you live on your own farm. Why not? But if we are in villages, we need to develop other options. So we need to consider that sanitation is not only recycling the nutrients, this is one aspect, but it's also to have access that you can clean your water, you can clean your hands afterwards, and that you have privacy, that you are that they are on safe places, that the place to go to the toilet is safe. So it's a matter of, I think, also these alternative sanitation systems means a lot more involvement of the local people. So to have also the debates and to have the discussion, what is an appropriate sanitation solution for us at the village or the city where we live. So that's also what Lisa said, like all the different actors need to be included, the users of the toilets, technology developers, the farmers that actually use the recycling fertilizers at the end, and many others. So we need to talk with each other.
Yeah.
Yes. So let's finish on that. Thank you all for listening. We are here today, tomorrow. You can come talk to us. Mainly find us in the Poo Garden or right now after this. If you have any more questions, feel free to let us know and let's talk openly about poo and let's not make this a taboo anymore. Thank you all.
Okay.